So how are you today? So class, did you find any difficulty in understanding our previous lesson? If so, you can visit or log in using your account to our e-learning platform, and you can go over to our learning path. And then you have to click the icon for the subject that you would want to explore or read more for a better understanding. So anyways, I hope you all prepared today. So everybody has to fasten your seatbelt, and in a short while we will going to take off with a new lesson for the day. Okay, so I would like to introduce our lesson for today. Is all about the formation of light and heavy elements. So class, I hope you can still recall in our previous lesson or discussion on the formation of the universe, where and how it started. Knowing that the most accepted theory about the beginning of the universe is the Big Bang theory. So, for now, we'll have to read first our learning competencies. So at the end of the lesson, you shall be able to give evidence and explain the formation of light elements in the Big Bang theory. Okay, so first let us have an overview to our subject for the second semester. So what do you all know about physical science? Okay, so physical science, it is a branch of natural science that studies non-living systems. So this is in contrast to life science. It turn has many branches. So each referred to as physical sciences are together called the physical sciences. Okay, so as you can see in this diagram, how physical science is being branched out. So this includes chemistry. So in chemistry, we have to deal more on about what is in the periodic table of elements. I'm sure you all know what you can find in our periodic table of elements. So you have chemical reactions, chemistry in the body. So what you have taken, so make sure that it is nutritious, or all of those are. Then next we have the physics. So when we talk about physics, it involves about energy and waves. Then you have here machines, force, the Newton's law of motion. Then you have the visible spectrum, light lenses, electromagnetic spectrum. So this fall under physics. And then it also deals with uh, force absorption, vehicles, special project, you have compound machine invention, bridge construction, environmental education. So all of this will be taken, or this will be discussed in physical science. Okay. So under chemistry, to be special or to be particular, you have here the periodic table of elements, chemical reaction, chemistry in the body. So this is also how chemistry is important. Now, we have to be familiar with some terms and terminologies in this topic. So you have to know about cosmology, Big Bang theory or the Big Bang model, nucleosynthesis, singularity, inflation, annihilation, recombination, the redshift, relative abundance, cosmic microwave background. So all of this we are going to discuss later. Okay, so let's have to define first the some of the terms. So we have here cosmology. So cosmology is a branch of astronomy that involves the origin and evolution of the universe. So from the Big Bang to today and on into the future. So as what they said, that the only permanent in this world is change. So meaning change can happen from day to day in our lives. So we cannot expect that kung ano yung nangyari ngayon, that would be still the same after few sometimes or after, let's say, uh, 100 years from now. So there is a possibility of change. Okay, so the three cosmic stages through which specific groups of elements were formed. Okay, so we have to discuss the Big Bang nucleosynthesis, the stellar formation and evolution, and the stellar explosion or the supernova. So these three cosmic stages are the one that proved to us, and they are also the one that is responsible for the formation of the elements. Okay. So we have the Big Bang nucleosynthesis formed the light elements. You have the hydrogen, helium, and the lithium. So these are the light elements in which you can find in our periodic table. So next we have the stellar formation and the evolution form the elements heavier than beryllium to iron. Okay, then we have the stellar explosion or the supernova form the elements heavier than iron. Okay, so we have to expound these three cosmic stages for you to understand how these light and heavy elements form. Okay, so what is nucleosynthesis? This is a process that creates new atomic nucleus from pre-existing nucleons, which is protons and the neutrons. Okay, then we have the primordial or the Big Bang nucleosynthesis. So again, this refers to the process of producing the light elements shortly after the Big Bang. So later we will discuss also the Big Bang. So the energy and the temperature of the universe are extremely high to cause the neutrons and protons to combine and form certain species of atomic nuclei in a process called nuclear fusion. Okay. So try to look at this diagram. This is the diagram of the universe and the formation of the elements. So it started from the Big Bang. You have here the light, the presence of the light elements, which is hydrogen and the helium. So if you look over, this is 15 from the year, no, 15 billion years. And then stellar fusion happened. Then what you have produced is the helium and iron. So 14 to 5 billion years ago, the heavier elements than iron were formed. So you have here the nova, or what we call the supernova. So this is how the protons and neutrons react and form energy. So the origin of light elements. So you have here the origin of all naturally occurring elements fall into two phases. So we have the Big Bang or the primordial nucleosynthesis. So this is the origin of the light elements and the stellar nucleosynthesis, which is also the origin and production of the heavy elements. So try to remember this one, that it started with the Big Bang or the primordial nucleosynthesis, and of course the stellar nucleosynthesis, which is the production of the heavy elements. Okay, so we have here now the Big Bang Theory. So the Big Bang Theory explained how the elements were initially formed. The formation of different elements involved many nuclear reactions, including fusion, fission, and radioactive decay. So part of its proof in these amounts of hydrogen and helium we have in the universe today. So this is how the story begins. Okay. So try to look at the history of the universe, where and how it started. So if you can see the timeline here, it started from the Big Bang, then inflation happened until today. Okay. Okay. So we have singularity. Singularity is a point in space and or a moment in time where the universe was infinitely hot and dense. So stars and galaxies that can be observed today were born as a result of the evolution of the universe. Then we have the inflation. So inflation is a theory of exponential expansion of space in the early universe. So this is how the Big Bang started until inflation comes in. Then you have here the cosmic microwave background radiation. Then you have the dark ages until the Daryan ionized universe and until the present or today. So these are the chief nuclear reactions responsible for the relative abundances of light atomic nuclei observed throughout the universe. Okay. So, nucleosynthesis, as the universe cools, protons and neutrons can fuse to form heavier atomic nuclei. So this primordial or the Big Bang nucleosynthesis refers to the process of producing the light element shortly after the Big Bang. So the energy and temperature of the universe are extremely high to cause the neutrons and protons to combine and form certain species of atomic nuclei and a process called nuclear fusion. Okay, so the isotopes produced during the Big Bang nucleosynthesis were helium-1, helium-2, helium-3, helium-4, and D7. An isotope is a form of an element that has same atomic number of the original element but with different atomic mass or mass number. Okay. Now we have the recombination. This refers to the epoch at which charged electrons and protons first became bound to form electrically neutral hydrogen atoms. Annihilation, in physics, reaction in which a particle and its antiparticle collide and disappear, releasing energy. So this antihydrogen consists of an antiproton with a negative charge and a positron with a positive charge. So if you can see the diagram here, you have here the light releases particle, then you have pair production, and you have the pair annihilation. So antiparticle goes with the light, and this particle and antiparticle pairs are produced from the light. Conversely, upon collision of a particle and the antiparticle, so pair annihilation occurs to produce light on annihilation of an antiproton and a proton or a neutron. So these are released in the first step. Okay. So we have here some evidences of the occurrence of the Big Bang. So what are those evidences that really prove the theory of the Big Bang? So we have the redshift. So the redshift is the displacement of spectral lines toward longer wavelengths. So the red end of the spectrum in radiation from distant galaxies and celestial objects. So if you can see the diagram, this is the object proceeding with the red waves, and the object approaching, we have here the short wave. And then we have the cosmic microwave background radiation, or the CMB. So this is an electromagnetic radiation left over from an early stage of the universe in the Big Bang cosmology. So if you can see here, you have here the periodic table of elements. So try to look at the light and heavy element. So we have here the Big Bang fusion, and then you have the blue one. So you have the blue one, so you have the hydrogen and the helium. So try to follow the color. So for the dying low mass stars, you have the lithium, carbon, and the nitrogen. And then exploding massive stars. Okay, you have a lot here. Then you have the human synthesis. Then the cosmic ray fusion, merging neutron stars, and the exploding of the white dwarf stars. Okay, so you have here the Big Bang cosmology, matter dilutes as the universe expands. So this explains the steady state cosmology. Matter is constantly created as the universe expands. So if you believe that the universe is expanding. So to summarize, the origin of heavy elements were formed only billion of years after the formation of stars. So you have to remember that heavy elements can only be formed billion years after the formation of stars. And the density inside a star is great enough to sustain fusion for extended time period required to synthesize heavy elements. So again, stars are hot and dense enough to burn hydrogen 1 to helium 4. So the formation of heavy elements by fusion of lighter nuclei in the interior of stars is called the stellar nucleosynthesis. So there are many nuclear synthetic pathways or nuclear fusion to produce heavy elements. So you have the carbon, nitrogen, oxygen cycle. And then you have the proton-proton fusion, triple alpha process. Layers near core of stars have very high temperatures enough to nucleosynthesize heavy elements such as silicon and iron. So elements heavier than iron cannot be formed through fusion as tremendous amount of energy are needed for the reaction to occur. So heavy elements are formed in a supernova. Okay, so a supernova, this is a massive explosion of a star. So after this massive explosion of a star, then here comes the heavier elements. So this supernova is the explosive death of a star. So now you know that there is a death, no? May hangganan din ang star. Namamatay din sila. Okay. So, in supernova, the neutron capture reaction takes place, leading to the formation of heavy elements. So, in a neutron capture reaction, heavy elements are created by addition of more neutrons to existing nuclei instead of fusion of like nuclei. So adding neutrons to a nucleus does not change an element. Rather, a more massive isotope of the same element is produced. So elements higher than iron requires tremendous amount of energy to be formed. Thus, they produce from a neutron capture reaction in a supernova. So there are three reactions that lead to the formation of the elements. So again, we have nucleosynthesis, the fission, and the neutron capture reaction. So this reaction required a certain amount of energy to proceed, which was obtained from heat and continuously expanding universe. Thus, energy in the form of heat does not only produce work, but also the elements that make up matter what we have today. So this reaction involved in the formation of these elements are dependent on the atomic mass of the elements. So more energy and thus higher temperature is needed to form heavier elements. So nucleosynthesis form light elements. So again, it is the nucleosynthesis that form the light elements, whereas fusion in stars form elements in an atomic mass that is within the range of beryllium and iron. Thus, any element with an atomic mass higher than iron, which required tremendous amount of energy to be formed to produce a neutron capture reaction in the supernova. Okay. So this nucleosynthesis form the light elements. So again, if you are asked, how did light elements are formed? So you can simply answer through nucleosynthesis. Okay. So through nucleosynthesis form the light elements, whereas the fission and stars form elements with an atomic mass that is within the range of beryllium and iron. Thus, any element with an atomic mass higher than iron, which required tremendous amount of energy to be formed, was produced from a neutron capture reaction in the supernova. So you have here the universal element formation. So the other 86 elements found in nature were created in nuclear reaction in the stars and in the huge stellar explosion known as the supernova. So universal element formation, elements are formed deep within the cores of certain types of star. Okay. So as you can see, it all started from stellar nebulae. So try to follow the arrow. So you have here the massive star. After stellar nebula, then it will form into a massive star. Then from massive star, it will form into super red giant. Then until such, it will become to supernova. So again, after supernova, then you have here the neutron star. So this neutron star is a celestial object of very small radius, typically 18 miles per 30 kilometer, and very high density, composed predominantly of closely packed neutrons. So neutron stars are thought formed by the gravitational collapse of the remnant of a massive star after a supernova explosion. Okay, so As you can see here, there is also a black hole. Why? So this black hole, if there is, the star is insufficiently massive to produce a black hole. Then you have here the average star, red giant, planetary nebula, and this will produce white dwarf planet. Okay. So we have to discuss the stellar nebula. So what is a stellar nebula? So moments after the Big Bang, energy begins to condense into matter. Protons and neutrons are formed. And then the first element, hydrogen, is formed. So as you all know, hydrogen is the lightest element found in our periodic table. So hundreds of millions of years later in the stellar nebulae, the hydrogen gas cloud collapsed and under gravity formed protostar. So nuclear fusion processes begin converting hydrogen into helium. So one example of a stellar nursery is the Eagle Nebula. Okay. So we have the massive star. So massive star more than 3 times the mass of the sun. Okay? So if you can just imagine how big it is, since it is more than 3 times the mass of the sun, mostly convert hydrogen into helium. Okay, Rigel is the brightest star in the constellation called Orion and the one of the brightest stars in the sky. So it is a blue, very hot supergiant over 100 times bigger than the sun. So do not think that the sun is the biggest in the solar system. Okay. So we have now the red giant. So this red giant is a medium-sized star exhausts their hydrogen content. They expand up to 100 times their original size to become red giant. So the nuclear fusion reaction occurring within a red giant are hydrogen to helium and helium to carbon. So our sun will follow this path over the next 5 billion years. So it took long years also to happen this. So this red giant is Aldebaran in the constellation Taurus. So if you want to observe this, then try to go out at night time, then try to look at the sky, especially if the weather is good, then you can see there a lot of constellation. Then if you know the form, how Taurus is formed, then you can simply point it out. Oh, that was the Taurus. Okay, so supergiants are the element factories of our universe. The nuclear fusion reaction occurring are helium, hydrogen, helium, helium to carbon, carbon to helium to carbon, carbon to neon, the neon to oxygen, then silicon and silicon to iron. We have here the planetary nebula. A planetary nebula is a huge shell of gas and dust ejected during the last stage of red giant of the life of a medium star. Elements such as helium, carbon, oxygen, nitrogen, neon, and smaller amounts of heavier elements are present. Planetary nebulae play an important part in the chemical evolution of the galaxy, allowing these elements to be returned to the interstellar medium. The remains of the carbon core of a red giant evolved into a white dwarf star. So the Eskimo Nebula in the Gemini is a good example. Now we have the supernova. I know you have heard the word supernova. So from the cataclysmic explosion of the supernova, the heavier elements form. So the supernova is the final stage in the life of a massive star. So the outer region of the star collapses and it instantly rebounds up the inner core in a cataclysmic explosion. The extremely high level of energy allows further fission reactions to occur, producing heavy elements like gold, silver, and uranium. Now, we have the black hole. Do you ever believe the existence of a black hole? Okay. So black holes are all that remain after stars with masses over 3 times that of the sun, supernova. So it is very big. You have to imagine how big the sun is. Then you have to multiply that by 3 times. Okay, a black hole is a massive object or region in space that is so dense that within a certain radius, its gravitational field does not let anything escape from it, not even light. So, kung mahulog ka dito, ambot maunsa ka. Because nobody have been there and no one can ever told us what is inside the black hole. But the black hole, they said it really exists. But nobody can explain what is inside. Okay. So, elements, planet, Earth, and us. We are literally the ashes of long-dead stars. So do you believe? Scientists believe that the solar system was formed when a cloud of gas and dust and space made of the elements formed deep within stars started to collapse, forming a solar nebula. This began to spin as it collapsed, eventually giving birth over billions of years to the solar system as we know it today. So apart from hydrogen and helium, formed just after the Big Bang, most of the elements we come into contact with have been made in the stars. Planet Earth and all of its life forms are made of elements formed billions of years ago, deep within the cores of stars now long dead.